Good evening, everyone. So, thermal properties of matter is in the last class when you got question PYQ when solve to will the low help the gay the solve to toga. See thermal properties of matter is so where were we? You know, see thermal properties of matter. See the kai po solve to gre. Kai gre. Okay. Rang it kai question number. See can was 2014 is Yes, 2014 22.5 targets. 2014 22.5 targets. They matangda question number 13 ka. Aduda sir nanuida theory oina takadaba ka saruk kaidoba. Theory oina takpa is inuida keno di ta outdreva ka. Adu haped keno dawsi ka. Latent hit ki matangda haitar. Latent hit ki graph to nui khangbra. Latent hit ki da. Adugi graph to adung keno ni ko samlapna haigi ko hape chalk mama pai la lawa so combine lay have matam dane sumaina let's see there and see there ko aduga magi si kedo we have the change of state lay gido ni ko na heat pisan matam da delta q hengala matam da temperature hengat pa ko so some site the temperature lay ni and some site the temperature lay ni some site na q ka heat lay ni ba so kedo we have matam da ihan han da sumaina lay ni then sumaina constant lay ni then sumaina lay ni then sumaina constant lay ni then sumaina khat krani bu ka so kedo we have matam da cgc ka cg state c kaino have that this is in the form of ice so kedo ni bu ka water gi ni ko sa temperature ga heat kai ta and this is 0 degrees Celsius ka see my pass this is 0 degrees Celsius ka and this is kedoba 100 degrees Celsius 100 degrees Celsius aita sisina kedoba 100 degrees Celsius ni ka aduna akoina kedo we have matam that this will be kedoba I see 0 degrees Celsius odai dum odai hena ka kanon to si ai duga nangna we have the until unless completely isomelt tawdragadi temperature si hengaloye buka aduna ngai ko aina sida temperature si 0 orgadi si negative orba negative oire buka so si negative oibu sidi we have the kuina si graph si jing da 0 100 degrees Celsius ka si marak si na this is liquid phase we doing ba liquid phase ka this is a liquid plus gaseous phase or this is a completely gaseous phase or any ka and this is a solid phase or any ka aduga koina khangadaba na ka sidagina c fawbaze sida kada we have the heat t ka heat t kano to absorb to gyan tai kai se but temperature the increase to deba auna sigi sibu kada we have matam that this q is equal to kaina have the l f m ka lfm ne ka duga sigi sidena c fawsina kayo dino have the ka this q's in a kaino sigi q's let's say this is q1 let's say this is q2 q2 is in a kaino lvm oigdene ko latent heat of vaporization ado sir gi graph si kitang kaino to what le habdi kaina sigi ne q2 sina q1 da yam hen gadam ne ba chaw si ko aduna sir gi di q1 abu kitang hen bai type to in tore si graph se so asengmadi ya asengmadi si ya dia de so maina ga kitang pnjra maina kitang pl lagade aduni hen saklo hen ko aduga sisi kitang ga thalena ko so simiam pulap si shift over yaribo ma'am kanoma kanoma ita kanoma wam haige to man but to get so sumaine ni ka aduna let's write this sisina sida thamage aduga sisina sida matakta thamage ba aduga ke we have the in general q2 sina hele ka aduna sisi any ke do wa keno gini ka kaheni again any keno haisi water dana budi khwaidi hina chane iduna water ne na khalo ka sisi the graph which depicts the relationship between temperature and heat supply ka to water haitare yare ko myam sigize yabra yayade
Yaisha.
aduna sisi de yamna keno ko interesting urjiko ino habda masagi ke doba sigi phase in a liquid phase where ni sidai ke doba ke mazi manin ka kat pahura ni bu ko ken dai ko aduga magi temperature sidi ke do we have the constant 100 degrees celsius sida boil to ba adi temperature sum hengala ni swai dagi dum manin ka bo di horani but 100 degrees di hello ya roba aduga completely steam ko oigra kanda di ko further temperature increase to we ani but liquid oina di boil to buda steam do in convert to rani temperature is swing hinga loiba ice sungare 0 degrees celsius stay hena swing hinga loiba ko water no form to ice kahani 10 degrees celsius taga laiba swing ya roiba it has to be 0 degrees celsius always ko or below ko kaigino hai matam da again sorry karam kandano have the at normal temperature at normal pressure hai tare ko atmospheric pressure then pressure change to ga di sida su change la kani ko yariba ma'am
Yaisha.
yari ko okay fine ko keno to wizi na ngai class yaw da ko new student na ma yawre z6 larpic hai ji kana odino no response habidi keno ni ko sir na sum mai dinangi do ming moina haptabni na aduna keni kaino to wai ta sir na gyan tarba kolabana hangadabu nan kanano khangdabni na sir na hangbudo frak ta na du gini yari gi hapon hai ji ka
sir ai ni sir
ai ni hai ji
ichi gi number de yaw
tang habiro ming habiro
adam
okay adam ka adam
yes sir
okay fine adam ka yeah sir na di gyan tarba hai hangmo to adam gyan tarba na hang na be wani da ming khangra ga di ka adu that's it so koi question solve to si ka si gi question number 13 si ka liquid oxygen at 50 Kelvin is heated to 300 Kelvin at constant pressure of 1 atmosphere. The rate of heating is constant. Which one of the following graphs represents the variation of temperature with time? So, sigi question zinoing amgadra paringo liquid oxygen at 50 Kelvin is heated to 300 Kelvin at constant pressure of 1 atmosphere. Yareko. Constant pressure. So the rate of heating is constant. Rate of heating the constant we have got. So which of the following graphs represents the variation of temperature with time? Now 50 Kelvin obviously we have the nangna negative to lay negative to kya layni 50 Kelvin 0 degree Celsius minus 273 ga manavani and 50 Kelvin 50 minus 273 la ani ko aduna 223 minus 223 Kelvin minus 223 degrees Celsius la gidini aduga 300 sina kaino 300 sina kedawa 27 degrees Celsius oiduna 300 sa kay di 273 to subtract or the 300 tagi 27 degrees Celsius neba and 27 degrees Celsius have z room temperature ga amha neba ko room temperature ji 25 oi 22 to adum 25 oi 27 ji adum room temperature ne have yai ko summer dagadi sometimes 45 year wo yauri ni 50 year wo yauri ne ko so kedo we have the kedo wa haziki liquid oxygen si ngasai ke 0 degree celsius yawu matamda kedo rani ha matamda masi gaseous state lakpa horani ko adi 0 degree celsius to oigera or minus some kahne minus 5 degree celsius minus 10 degree celsius or minus even 20 degree celsius ta masi liquid tagi gaseous state lakani ba kyan tai ko tabra ta dabra kai di oxygen is normally kai state lay liquid state lay ba aduna graph si kai we have the constant rate of heating p ba matam the graph si da ngasagi phase change ama show to gadabne ba gyan tai ta de ma'am
Yes, sir.
tai ko awna quite first na maji kai doroni liquid state layer maneba liquid state tagi kai doroni have the same temperature de hiche adum absorb to orga masi kai dorani liquid tagi gaseous state la ne and gaseous the low in converter kan the temperature increase to orga ne ba nuna latent heat ki kai do ba saruk ama yaw ga da ne ba kai di phase change ama yaw ni na option number kai tarni
E.
option number A tarni ko yarbo ma'am
Yes, sir.
Yes, sir. Okay, fine. So, makata uzika do that. Okay. Question number 14. If 1 gram of steam is mixed with 1 gram of ice, then resultant temperature of the mixer is, and I have a call. So, sigi resultant temperature is kya wini khangbra? Sisi dino kano putok tragadi yaro, latent heat ki kano the value do khangragadi yaro ibaka. So, aduga kedoba principle of calorimetry pan gadine baka. Obviously, 1 gram of steam si temperature kya hoyamni 100 degrees Celsius. 1 gram of ice in temperature kya hoyamni 0 degrees Celsius. Now, temperature is 50 the lakadra. Lakadro? No response. Kay yun kanam to respond to optizibo. Khang dragazu khang de sir natragana lakani sir la oi sir whatever adu hairo. Sige sir 1 gram of steam ze 1 gram of steam is the yauri but heat se sisi kaino hai matam da ngasai masi the kedoba 1 gram of steam is the yaudu si ngasai magi ko specific heat ama yarni ka ke 1 gram have dina mazi even adum kedoba yare dum specific heat harzi ka. So we know S is equal to kind of the delta Q by M into delta T ne ko. We have the specific heat into 100 hai tare ko. So my layer ni plus haraga we also know L is equal to delta Q by M. Auna LM yaudu ne but LM do di kind of the okay, let me write M here ko. The M zino M ka kind of tawdre na kan batare. Auna 1 gram the yaudu is sigi sang zine gyan tai ko haisa aduga 1 gram of ice 1 gram of ice di ka yaudu ba 1 gram of ice di magi ba my temperature si ba 0 degree ne ba ka aduna my si heat si kanta yaudre lower se ba ka 0 ne so sisina kaina 100 degree Celsius ni and sisina kaina 0 degree Celsius ni buka audi we have 1 gram of ice ka 1 gram of steam ga sa ani si mix to matam the temperature si mayam khangbra kai lakani no response 100 degree Celsius ta dum lai ga deni noi khangdabra si gi sa
Khangde, sir.
Khangde ka okay fine ka sir na adi kedoba I'll explain don't worry ka taro ka muna taro Ngasaygi kainusi ko latent heat of fusion se latent heat of fusion ga latent heat of evaporation gisi values yam khenei ko sir nan noida happy chalk ma kaino tograba latent heat of fusion na sini latent heat of kedoba evaporation na sini habda
Masing na sir.
Latent heat of fusion do kaya no some around 530 kaya
80 calories per gram.
80 calorie bra 80 calories per gram aduga kay amazina kaya taba latent heat of evaporation na
530 oh
530
ano di sir kitang what kayo mali
kailan to give the sir na nahan with the 533 haira
kilo
okay 533 kay calorie per gram ne ko all right fine now aduga amana do we have the specific heat of water na kya no no response
sir CDP로 khangdiye
asidi khangdi specific ma sisu noi khanggadabne specific heat of water
beru
cc 1 calorie per gram oibra ko asi myam de noi loi khanggadabne ba adu ergadi yare ko adu ergadi kay
latent
haba
heat vaporization je latent heat vaporization je
suppose nang ngangi de tumangi de na sir gyanam tadre kay have no
latent heat of vaporization je 536 kilocalorie oiba male kilocalorie char calorie
kilocalorie di per gram oibra ne gram an lakra ba
oh sorry sir ki par kg wala
yare ko de
yeah sir
all right fine so sigi matang sida ne noi khallagi yengo ba ngasai gi kedoba ice se cc 1 gram of ice 1 gram of liquid water the convert to matam da heat kyam changi only 80 calorie change ba and cg 1 gram of liquid water si kedoba 100 again this is still kind of 0 degree celsius ni ko aduga si ju kind of 0 degree celsius ne ba so cg 1 gram of water se CC के दो we have मतलब द 100 degree Celsius ता पूरा के हायर गद्दी heat क्या हम चंगी 100 calorie चंगे वा अब ना 100 plus कहीं ना 80 अदु दी क्या ना 180 calorie ने बता काले इसे अब ना 180 calorie दु दी सी की steam की 533 calories इधर की माना 433 calorie दा हंडर रखो मतलब दा sorry 533 minus 180 है तारे का 533 minus 180 khaidokiba matamda mado mangonda kaidoni ha matam hitse dama dam yawriba 3 layer ni 5 layer ni aduga kaidowa 3 minus 1 ko 253 calories already yawriba si haziki steam jida aduna di kaidoni ha matamda ngasai steam kharadi water da convert tauthokrani bako adubu still 100 degrees celsius ta dum laini ba aduga ngasai 1 gram of ice to madu kedoba 80 calorie si mangona phangba matamda 1 gram of ice tagi 1 gram of liquid water do olani and the hazik kedoba hazik there is no more ice left ko kaino 80 calories phangba dai ma 1 gram of water liquid water do on gre now see 1 gram of liquid water si da another 100 calorie ambition matamda 100 degrees celsius da lakreba auna common temperature si kayo ni 100 degrees celsius oini ba gyan taita de
Yes, sir.
Okay, fine. Atay di tarbo? Adam tarbo? Sita boss?
Tare sir.
Okay, fine. Lakshmi? Anjali taudro ba zikita?
Yan. Sana ako taba, do taba yung kahit.
Nga mo siyang din ito. Sir na hai se, gyan taba yogdri ra khang de hai ra.
ꯌꯧꯗꯦꯕ ꯑꯩꯅ ꯈꯪꯗꯕ
nang khangdraba ko adu se ko sir amukka ken toge ko amukka explain toge it's a very simple one yam live poni kidarga ngasai gi ne ngasai gi si ke do we have the steam zidane it's a tar ko ngasai gi akoina 1 gram of steam ze cc for example let's say you have 1 gram of ice ko 80 ga 100 ka let me just stop let's say you have 1 gram of ice now sigi ke do 1 gram of kaiba ice sida nang na ke do we have the 1 gram of liquid water the convert to ge har ga dinang heat cam supply to dino 80 calories of heat si supply to matam da 1 gram of ice tagi ke do 1 gram of ice at 0 degrees celsius tagi 1 gram of water at 0 degrees celsius phanga doine ba kyan daita de tare ko now haji akoina 1 gram of ice 0 degrees celsius ta dum lay dune ba ko ice tagi liquid water da convert to matam da kedoba I have to give kaya 80 calories of heat and then sigi 0 degrees celsius ta label liquid water je ice tagi liquid water on gre ko 0 da same temperature 0 da now sigi 0 degrees celsius si amuka kedoba aina kedoba 100 degrees celsius ta purok matam da 100 calories pirane ba adu kya sure 180 calorie leire ko now hazik 100 kedoba degree celsius ta leiba 1 gram of water se at 100 degrees celsius ni ko boil to lei dune ba sigi boiling water se completely steam da convert to ge hargadi I have to give another 533 calories of heat so total se kya tare 80 plus 180 plus 533 this much amount of heat si ngasai gi steam du da yaw du ne ba as compared to the ice gyan tai ta de tai ko adu targadi kedo wi ha matam na ngasai gi ice siga ziga ani si lemina matam da higher temperature ga lower temperature ga higher temperature the heat si kedo kani ha matam mo ni si common temperature ma lak no hun of the heat transfer to ra ne ba aduna minus ngasai gi som da lei ba 0 degree celsius da lei ba solid ice se si si na kwai first da kai han lower ni som da gi 80 calorie lower ni mana 80 calorie lower ga mazi solid ice da gi kedo ba water da liquid water da convert to ne ba at 0 degree celsius da do then mana okay 100 degree celsius am loksal mazi 0 degree celsius ko water do liquid water at 0 degrees Celsius tagi 100 degrees Celsius ta laiba boiling water to convert to grane so it needs only 180 degree sorry it needs only 180 calorie so ngasai gi som da heat se tap ta yawe ba steam jida ana steam jida gi heat loina ma pitoko yaudringai da ngasai gi ice to mel su to ni 100 degrees Celsius su la ni ba gyan dai ta de gyan ta de
sir
sir
yani ko aduna steam da yawi bi hitse aduki matik chawe ba ko aduna steam da loina mak kedo we have the adi 1 gram of steam ze sisi loina mak liquid ta convert to bon nang dringai da ngasagi ice to 1 gram of ice to mel su to rani 100 degrees celsius ta jula ne boil ju to ne yan dai ko isa aduna steam kharabudi ma liquid state ta chat khrani but loina mak chat pang nang moi ba kai ni hit to dik chawe 1 gram of steam there hit yani ko okay okay now question number 15 did you 10 gram of ice cubes at 0 degrees celsius are released in a tumbler water equivalent 55 gram at 40 degrees celsius assuming that negligible heat is taken from the surrounding the temperature of water in the tumbler becomes nearly higher kai ta den have sising amgadra ngamoidra yan dai ta this okay noi ngam dau man re sigise ko sir dum tawrage yengsi ko sigise sida lazy kaino aduga moin solve to hai assuming that negligible heat is taken from the surrounding the temperature of water in the tumbler becomes nearly okay so I have what 10 gram of ice at 0 degrees Celsius haitare ko. Now CC are released in a tumbler water equivalent at 40 degrees Celsius. Aduga CC ga and somdana I have 55 gram of water. Yare ko. And magi na temperature sina 40 degrees Celsius and 10 gram of ice temperature na 0 degrees Celsius never ko. So assuming that negligible heat is taken from the surrounding, the temperature of water in the tumbler becomes nearly. So magi temperature is kya ho do not have never. Gyan tai ko aisa. Adu iba targadi ngasai 10 gram of ice melt over matam da kya changni have da 800 calories changadra. 800 calories. Ko. Sigi 10 gram of ice dane kaidawa sigi ne 800 calories of heat say in a pishan matam da mazi kaida lakani have the kaida converter we have the 0 degrees Celsius of water the converter enable ka aduga sigi 55 gram of water at 40 degrees Celsius never ka aduna 55 gram of water at 40 degrees Celsius so 40 into 55 mangonda yauriba heat say sisina kaino have the delta qz kaino have the s into m into delta t never ka so what is m what is SST? 1. What is M? M the 55. And what is delta T? Delta T the 40. So 0 layer 5, 4, 20. 5, 4, 20, 22 I tire. So 2200, okay. 2200 calories of it. Yeah, 2200 huge specific hit calorie minus this is calorie 2200 calorie yaw adudi temperature do ko na water di temperature puto am ne adudi ngasai ne 10 gram of ice mana ke doni have 800 grams lawthokro so 2200 minus 800 subtract or odi kai tare 0 0 so 4 and 1 ko so 1400 calorie le me ko now kedoni ha matam da sigi 10 gram of kedoba ice cc 0 degree Celsius taina yung ko sigi sa latent heat level ko magi aduna magi kedowi q1 harage ko is equal to haraga kay when you have the lm never so which is equal to 800 Matangda Q2 is equal to S into M into delta T. And what is S? ST1. What is M? M di kayo, M di T. And what is delta T? Delta T is a common temperature. T nila T minus harga kayo already 0 never. So T minus 0. Sila nebuko. Aduna hazik kedoni hamatam the 800 plus 10 T should be equal to ngasay mana hit si mangunda na kaya yawa 2200 ko 2200 calorie of heat yawa do ne ko aduna sigi si ina 40 haibe mahutta common temperature to the chat ka dini ko cg 40 haroige sumainen hagi yo question gi maka pola itare ko si delta t ni dana aduna cc degree Celsius le am 40 minus t harage si sina ko so adu ergadi kaino abda again has ikito dum hayabra 2200 minus 55t so this should be equal to 2200 minus 55t le ni ko adu ergadi sigisi pura ergadi 65t so adu si asompura ergadi 800 adu 1400 kedoba divided by 65 le ni ko aduna kaitarni 515 5315 5210 5840 so 280 by 13 so 13 113 13 226 ka 13 amuka 13 to amuka 26 ka 22 degrees Celsius ta abra ma'am sige se amte yung
Tai sir 22 degrees Celsius.
22 degrees Celsius ka so sir na solve to is gyan ta abra gyan ta de Ngaubra. Here you have with over 10 gram of ice. And you have another you have around 55 gram ko. This is the 55 gram of water mana 40 degrees Celsius ni ko. And this is 0 degrees Celsius ni and mana 10 gram of ice ne ba. Gyan tai ba isa. So sige na 10 gram of ice sida na. Moini si common noina moini si mix hek tong no ba matam. Kaidongni ha matam da ngasai ba 10 gram of ice se 0 degrees Celsius se mana heat si low raga masi 10 gram of liquid water da la aneba. So adu the low gudu heat to the kya no 800 calories mana absorb to gudu neba. And then maji kaidongni ha matam da after after changing its state from solid ice into liquid water, it will rise its temperature we'll see a rise in temperature. And adu kaya no adu khangde aduna si delta t to t minus ma 0 day hengalakaduni 0 day rise to t minus 0 ha geba. But adu gi hit mayam du kana na p du no ba. Nasai 55 gram of water do na p du ne ba at 40 degrees Celsius. Auna magi di am ka hit loss to du kya no ha matam da SM delta T. So for T dagi some common temperature T in the tarakadwini bako. Auna sisina aduna neither we have the isumina hot cake on gan tabra tadabra. Aduna CC and easy kedawa. Yen easy mixed on a nebako. On a mixed on a matam the net. Kedoni hamatam da you have this. And this is heat absorb ko. Aduna sigisina sumainle ni hatare ko. Sidagi si amula ni then to the si sumair. Yare ko. Aduga amana kedawi hamatamda. Let me amazina. Let's say this is Q3 and higher saver ko. Let's say this is Q3. This is Q3 ko. Aduga 1 second. Sorry, presentation you know hegiem ga gyanta na we one na Q3 sina sumaine ni ko do oibetar ga di 3 tabre 3 fakta horizon. Okay, fine. So, according to the principle of calorimetry, kayo ini hamatam da heat absorb should be equal to kay sisin nakanda thamgrage ka. Negi si kena tawte gyan tadawai type ta sum taw isi kay ngangdi na gyan tadra jala ngdi ne. Heat absorb should be
Yes, sir.
okay, thank you. So heat absorb should be equal to heat release never ka. Our heat absorb sidi kay no the Q1 plus Q2 never should be equal to Q3 never ka. Aduna kaina sumaina walaga this is equal to kay 22 degrees Celsius and sumaila never. Yarbo ma'am sige
Yes, sir.
ka. Atay kaya tawda mi yaubra yada mi yaubra. Lakshmi, Sintoy, Anjali, Christina, Adam, Saitabos, Sahila. Yarbo?
sir.
Yes, sir.
Yare ko. Singi ko. Do nui still doubt labor macha ama or whatever sir kenogi horok step 2 na travel last key or may key or whatever sigi maptang jigyan tate and the hagadim the harobo ko Sintoy yarni. So anyway, fine. So mind solve to any question ji them. See, this is an AC principle of calorimetry. Never see. sorry noina khangadoise main oina sisima khango n kaidobagi kai siziga ta q1 plus q2 sina hit chikidoba changi doineba absorb and q3 sina kidoba hit chi pithora kadoineba ka q3 sina out q1 and q2 sina in adana. All right, fine. So let's do the next question. Heat transfer cost. The power radiated by a black body is P and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at this, the power radiates. So it's a very simple question. When's displacement low palaga? Is it when's displacement low? Power in a P ka lambda. Okay, no the lubi I start okay ka. See Stephen Boltzmann's law oigadra yengsi. Yes, there you go. Lambda naught. The power radiated by a black body is P, and it radiates maximum energy at wavelength lambda naught. If the temperature of the body is now changed so that it radiates maximum energy at 3/4 lambda naught, the power radiated by it becomes n times of P. So the value of n is okay, fine. Now, akoina aduragadi sigisida kai ningzingni hamatamda akoina lambda m ko natragasudum lambda naught aizra. Let's say lambda m sarana p gibada doina ko no textbook to lambda m hamal is equal to b habam lere ko. And then Stephen Boltzmann's law gi matungina p is equal to e sigma a t to the power 4. Sigi, you have this two laws ka. So sigi law uneasy. When seasonaraga sigi small n gi values in a solve tauga to never. Can ka? At wavelength lambda naught. So p matamda e samanarni ka. So let's say p matamda e lere sigma lere ka. Then a lere aduga t zidi kai have the b by lambda naught to the power 4 lere ka. If the temperature of the body is now changed so that it radiates maximum energy at 3/4 lambda naught, aduragadi the power radiated by it becomes n times of p matamda e sigma a harga IC khangdeba ko and see b by harga okay then we have the okay fine 3/4 times of lambda naught neighbor ko. So divided by 4 so my la neighbor. So you have to solve the value of n. How this is they solve the okay now. Let's say this is equation 1. Let's say this is equation 2. The equation 2 divided by equation 1 gives n is equal to harga makagi ka okay into line sing to kitong kay tarni no idum khangamani yeng answer khangaba khangdriba sisida amasina yelakadoine buko aduna 3 to the power 4 by 4 to the power 4 by 3 to the power 4 tarni. So it is basically 256 by 81. Option number C tabra ma'am. No response. Okay, fine. So we can already discern question hang with the kaka kuma di padone prom point ko mi amani katang kume. Lakshmi gyan tahudraba.
Tahu sir.
Aika. Sunanda tahubra. Presenta driver ka. Kintui dagi keno no iskra topo male sintui. Keno thamjala. Mid thamjala. Okay, fine ka. Sahila gyan tahubra. Sahila boss. Okay. Anjali tare ka.
Tare sir.
Aduga keno di Adam di ma keno tole net chappaga le joining harga changak pa yada le lo insure ka noi le suitable stare insure ba okay fine yare ka so sumai legi de it's a very simple question noi aduna law ani ji khangum da ka ta e ko sigi law ji noi kaogra ba khangbra sigi da delta q by delta t t ni ko small t ni ko temperature is equal to haga e sigma a t to the power 4 tawil do yai ko adu do delta q by delta t the power ne ba ko adu gin sumain to si ai. Now let's move on to the next question. Two rods A and B of different materials are welded together as shown in the figure. Their thermal conductivities are K1 and K2. The thermal conductivity of the composite rod will be. So it's a very simple question, but very simple. And we can kang the yade ka magi formula to kang the yaro formula is derived the whole male. So I have to derive the formula first. Parallel ga series ka ka kamain to ge have do. Okay, adum to lore ka sisi da. Edi sisi gidamakta tongana theory and formula derive to dragasu yahal lage ka. Kamain to ni have the let's say sumaina road amle ka. Another road am samjana ka. Aduga sisi na temperature T1 neba, som na temperature T2 neba. And some marakta temperature T yamalay ko. My conductivity na K1 neba, my conductivity na K2 neba. And total gi kaidawa abdi sisi na KS harage ko. Adu ergadi akoina kaidawi hamatam the heat flows e. Kaila can have the delta Q by delta T is equal to haraga kaidawa K1 A by L haraga T1 minus T tarni. Aduga same delta Q by delta T is equal to K2 A by L T minus T2 tarni ka. Aduga same delta Q by delta T is equal to KS series lower ka A but area but length twice L la ni ka same dimension in low dini aduga T1 minus T2. So C is akoina solve to matamda. If we solve all these three, what do we get? Akoina kay fangi matamda kay le ne durga de sigza. Akoina T1 minus T2 ni na ko. C equation 1 harage, C equation 2 harage ko. Adurga di nang na kay gumba equation 1 2 ko sum to targa di T1 minus T2 ko di pangbra. Pangi ko. Yes, very nice. So nang na 2 times of delta Q by delta T. The equation 1 plus equation 2 gives C to targa di nang kay pangi matamda okay, but again T1 minus T2 ko. K1 ga K2 ga C manadam ni na sum to yagadro. Yeah, right? Adur kadi kita wana funny. K1 K2 ko T1 minus T amana T minus T2 ne ba ko si sum to san no matam na K1 ga K2 ga si manadra gadi yagadra ne yaroi. Anyway, let's just see ko A by L is common or ni aduga K1 harga kay K1 T1 minus K1 T plus K2 T minus K2 T2 A by L ne buka sile buka aduna sisida serna makazida amazing torage ka som sai ki sidi kaino delta Q by T di 2 hani aduga A by 2 sida KS la ni ka saman graba kaino to ba yeng manung right aduna si kitang satoke ka aduga sida KS la ni habidi serna sigi delta Q by T ze C mahutta ina C hapsan lini ko sigi sida 2 into delta Q by T sida ko ina C hapsan ba audi kaila ne have the A by 2L so 2 ga 2 cancel sakre ba ko adu kaila kani have the T1 T1 minus T2 la ne sigi aduna CC kayo manani have the C mi have the manani cha manana ko steps challo iduri ka ina adu ga di C ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕꯗ ꯁ꯭ꯇꯦꯞ ꯑꯃꯇꯪꯒ ꯍꯥꯞꯈꯤꯒꯦꯀꯣ ꯁ꯭ꯇꯦꯞ ꯑꯃꯇꯪꯒ ꯍꯥꯞꯀꯦ ꯈꯤꯇꯪ ꯆꯤꯜꯂꯦ ꯑꯩꯒꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯗꯤ ꯀꯩꯗꯧꯕ ꯁ꯭ꯄꯦꯁꯁꯦ ꯁꯤ ꯀꯣꯏꯁꯟꯁꯤ ꯁꯣꯜꯕ ꯇꯧꯕ ꯊꯤꯑꯣꯔꯤ ꯍꯥꯟꯅ ꯗꯤꯔꯥꯏꯚ ꯇꯧꯗꯕꯤꯗ ꯅꯝꯐꯨꯗ ꯁꯣꯜꯕ ꯇꯧꯁꯟꯕ ꯅꯨꯡꯉꯥꯏꯇꯦꯅꯀꯣ ꯇꯧꯕꯅꯤ ꯁꯣ ꯁꯤ ꯂꯩꯔꯦꯀꯣ ꯑꯗꯨꯅ ꯁꯤ ꯂꯩꯔꯦꯀꯣ ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ ꯀꯩꯗꯧꯏ ꯍꯥꯏꯕ ꯃꯇꯝꯗ a by l ꯁꯨ ꯂꯣꯏꯅꯃꯛ ꯀꯦꯟꯁꯦꯜ ꯆꯠꯈ꯭ꯔꯅꯤ a by l ꯆꯠꯈ꯭ꯔꯅꯤ ꯑꯗꯨꯒ ks ꯍꯥꯏꯔꯒꯀꯣ ꯑꯗꯨꯒ ꯃꯁꯤ ꯀꯩꯅꯣ ꯍꯥꯏꯕꯗ ks is equal to 1 by t1 minus t2 ꯍꯥꯏꯔꯒꯀꯣ ꯁꯤꯒꯤꯁꯤꯗꯅꯦ ꯅꯣꯏꯅ ꯀꯩꯗꯧꯅꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗ tꯒ tꯒꯁꯤꯗꯤ ꯐꯔꯛ ꯇꯥꯕ꯭ꯔꯥ sida t sida ꯑꯩꯅ t3 ꯒ ꯏꯔꯛꯏꯁꯦ ꯀꯩꯅꯣ ꯑꯣ ꯅꯠꯇꯦ ꯁꯤꯗꯤ t2 ꯅꯤꯀꯣ ꯑꯗꯨꯅ t1 ꯗꯤ ꯁꯤ ꯂꯩꯔꯦꯀꯣ t1 k1 t1 minus k2 t3 something kaidano problem am lereko aigise derivation se kaida problem lay there seems to be a problem so area of cross section manarni length t amana l total length na 2l sangani ko aduga moini gi kidowa temperature se aina marakisi t ne option ba aduga apunbagi duna t1 minus t oiba kem kaidigi heat conductivity is sida kain frak taide t1 minus t2 ko k da keno tawgodone t1 k1 t ga k2 t ga jika pairam dreba ko aduna k1 sida common loba yaroi t1 sida common loba yaroi there has to be something t ohum si kamaina related oi t1 minus t and t minus t2 t1 ga t ga t2 ga si combine tawraga related oi habduma ka dudum tawgodoineba so 1 second ka somewhere kaidano maina miss tawba ma yawre adugidu kena dawsi ka titoga kena dawsi so there seems to be a problem and I don't get it ka so akoina kaidawi ha matamda t1 minus t ga t minus t naught ka adumain tawraga oina sum tawraga compare tawna fabra fai ka adu oiba taragadi aina t1 minus t naught an haraga adumaina k da nga to in thamba ka aduduna hena farani ka ai motadi so let's do one thing ka ma'am yem ko sigise sarna sigisi sumain tawbai muhutta sumain tawbi yem ko equation 1 implies t1 minus t1 minus t is equal to yem ko sise l by a haraga k1 delta q by delta t yabra sigise yaiko equation 2 implies haraga t minus t2 is equal to l by a haraga 1 by cc 1 by lakadamni ko l by a 1 by k1 oidiba sisina 1 by k2 haraga delta q by delta t oidiba yabro yaiko aduna kaidawi ha matamda cc let's say this is equation 3 and let's say this is equation 4 aduna 3 plus 4 gives si sum taw matamda t1 minus t2 lerni aduga sidi kai lerni ha matamda noina l by a ler ko so l by a harga 1 by k1 plus 1 by k2 ꯂꯩꯔꯅꯤ ꯑꯗꯨ ꯁꯤ ꯗꯦꯜꯇꯥ q by ꯗꯦꯜꯇꯥ t ꯂꯩꯔꯅꯦꯕꯀꯣ but ꯁꯤꯒꯤꯁꯤꯗ ꯂꯦꯡꯁꯤ ꯀꯩꯗꯧꯏ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ ꯂꯦꯡꯁꯦ ꯁꯤꯁꯤ ꯑꯩꯅ ꯌꯦꯡꯉꯨ ꯁꯨꯃꯥꯏꯅ ꯊꯝꯕ ꯌꯥꯕ꯭ꯔꯥ ꯌꯦꯡꯉꯨꯀꯣ ꯑꯗꯨꯅ ꯗꯦꯜꯇꯥ q by ꯗꯦꯜꯇꯥ t ꯁꯦ ꯁꯤꯁꯤ ꯑꯁꯣꯝꯗ ꯄꯨꯈꯤꯕ ꯇꯥꯔꯒꯗꯤ ꯀꯩ ꯂꯥꯛꯀꯅꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗ a by l ꯍꯥꯏꯔꯒ again a by l ko t1 minus t2 sumain thamageba aduga sigi potsi 2 times of k1 k2 is it 2 times nate k1 k2 by k1 plus k2 haraga sida 2 hapaga sumain leba so adu oiba taragadi kai leani ha matamda ks is equal to 2 times of k1 k2 by k1 plus k2 therefore haraga series ta samba matamda si tarne buko yabra ma'am sigise yeng ya de
Yes, sir.
ya karamba step gyan ta de sir ne ne noina section ga dabam na sir na sida 2 ma paise hana yaram deba sida jo hapane ba kathanaraga dum chamana na ba na ko ana sigi 2 je kaino ha matamda pull up ki di 2l ni dana asangbudo aduga pull up tadi temperature difference t1 ga t2 ga ni dana ko but area of cross section dim chap mane e dum oi leitu ni ba ko ana sigi 2 sida neba sir na sanari je auna aduduma fazana khango kaino jibo oh my god okay sigi 2 ziga ko sini da ano sanaga do adu iba taragadi sigi si question whatever 2017 ki question jam la ni ko are welded together and their thermal conductivities are this and the thermal conductivity of the composite rod ay moini composite rod sigi thermal conductivity putho u na haiba ko adu ergadi si kaino moina toise somdagi somda chattoy natra sumai nakan da chatpadudi it makes no sense now sigi t1 t2 sina kaino moini la le moini si t1 ji somda igadam ni ko the t1 should be here and t2 should be here right there adu ergadi habdi it makes no sense di sumai le ergadi ko aduna magi area of cross section si kai area of cross section depend tawra tawde ko 2 k1 k2 by k1 plus k2 di yawba yawde sumain chatpa parallel moi gisi kaino it's my see kainom to ika parallel sisina kaino oidura parallel oibagi parallel oibagi delta q by delta t is equal to haraga k1 ka a area of cross section a by l haraga t1 minus t2 or neighbor ka amazidu dum delta q by delta t but again mogi si di delta q1 and delta q2 harane k2 haraga a by l t1 minus t2 harane ko aduga pull-up ki apunba gidi kaino habda delta q1 plus delta q2 by delta t is equal to haraga some k p parallel area si 2a lani ko length ti l ni aduga t1 minus t2 ne ko sumain lani aduna sigi kp si aina sida compare tawba matamda kamaina compare tawbani habada 2 times of kp aduna siga sum tawba matamda si ani sum neba basically si equation 1 ni sina equation 2 ni ko adudi ani sigi sum mai tai auna aduragadi na k1 plus k2 z twice kp ga manare ko sigi equation sigi matungina so let's do one thing ai sigi page si kena to thoke ko amuka replicate to thoke duplicate to thoke ko So C natraji kida, yes. And then let's do one thing. Kaidoba, specific ka. Sorry. Coefficient of thermal expansion is the ka. Coefficient of thermal conductivity have a ka. Coefficient of thermal conductivity harga number 1 the kai sisina parallel sorry this is series ka. Series connection. Now duga series na kaino have the sisina parallel connection ta ni ka. So parallel connection gidi si question jile ni sida dum solve tau tharage ka. Aduna let's say this is equation 3 aduna CCD kai tarni hai matam da ne kp is 2 times of kpz k1 plus k2 ga chap mana ne so it implies kp is equal to k1 plus k2 by 2 tare ka. So option number D is the right answer. Yung amta yadra myam sige ja
Yani sir.
Yani, sir.
yani
Sir, ando,
Hmm.
aside series ONGD, kumain sa mo. Hadi,
kay hai ba hairo
kaya ne series kaya
parallel ni series ne ji kamai khang duino ba parallel ni series ne ji kamai khang duino ji moi gi temperature khutam ji da the parallel
ꯃꯊꯛꯇ ꯂꯩꯔꯝꯃꯒ ꯑꯃ ꯃꯈꯥꯗ ꯂꯩꯔꯝꯃꯒꯅ
sumaina T1 sumaina T2 ꯑꯣꯏꯔꯒꯗꯤ ꯁꯤꯁꯤꯗꯤ ꯀꯩ ꯑꯣꯏꯔꯅꯤ series ꯑꯣꯏꯔꯣꯏꯗ꯭ꯔꯣ
ꯑꯣꯏꯅꯤ
ꯌꯥꯔꯅꯤꯀꯣ ꯑꯗꯨꯃꯥꯏꯅ so ꯃꯥꯒꯤ ꯇꯦꯝꯄꯔꯦꯆꯔꯗꯨꯗ ꯌꯦꯡꯗꯣꯏꯅꯦ so ꯌꯥꯝ ꯂꯥꯏꯕꯅꯤꯗꯀꯣ ꯅꯣꯏ ꯑꯗꯨꯝ ꯍꯥꯏꯗꯤ ꯅꯣꯏꯅ ꯀꯩꯒꯨꯝꯕ ꯀꯩꯗꯧꯕ heat conduction gi law ꯍꯥꯏꯇꯥꯔꯦꯀꯣ coefficient of thermal conductivity do or adudugi kainodo haitare specific heat conductivity ka or coefficient of thermal conductivity whatever specific nate coefficient of thermal heat conductivity se sigi kaino je khangaga di adudi dum yam laire ko noi dum sabak sajin taw yare. So let's move on to the next question. And what is the time? Sorry, 9:22 ka. So sigi question jung yang ka a spherical black body with a radius of this if the okay fine. So it's a very simple question. No ingam gadra ngam moidra sir dum tawjira. matam mangan da bidai sa dum tawjara ke ko na khumaktre. Sigi question jing ngam gadaba mi yaubra. Anjali Sunanda ngam gadra Lakshmi Seta boss Seila ngam gadra kanam khumaktre.
Don't mind this.
ꯉꯝꯗꯧ ꯀꯔꯤ ꯄꯥꯟꯗꯣꯏꯅꯣ ꯈꯪꯗꯦ
Kay pandino kang dia. Mo is the power pyramid. Power is equal to 450 watt. Aduga temperature is equal to 500 Kelvin. Sinthui ngam gadra sinthui kumaya sida ka. Ngamni sir okay great. Aduga magi radius sina kaino 12 centimeter pyramid ka which is equal to 12 into 10 to the power minus 2 meter haitare ka. If the radius were half and the temperature doubled, okay, fine. Already the power radiated in watt would be. All right. So akoina kay khangi matamda power P is equal to black body nina small e do e da yarni sigma a t to the power 4 neba ka. So aduna ahambagi sina kaino habda 450 is equal to sigma harga 4 pi 12 square d 144 into 10 to the power minus 4 into t to the power 4 500 to the power 4. Aduga akun bisina the power P is equal to sigma into 4 pi into 12 ki tanghai di 6 ni dana ka 6 square di 36 into 10 to the power minus 4 into if the radius of where half and the temperature double, so 1000 to the power 4. Yareko, see equation 1 and this is equation 2. Adudi am light ro adudi. Noise adudi noise solve to ro. Kaitane hero. Yes. Sakauji kino to re. Hinga taksangi. Okay, fine. So now sidagi di noi makata abdi solve to bunga madra. Kumaro kanamta. Equation 2 divided by equation 1 gives P is equal to C plus B and Tokuma Tamda 450 into 2 never count 36 the kanani and 144 na yen diba. Aduga kay Sigi 1, 2, 3 divided by 500 power 4. So CCD kay tarne the 5 to the 10 2 to the power 4 aduna 450 into 36 by 144 into 2 to the power 4 di kay na 16 na tra. So si tarne answer 12 na ko 12 12 12 3 36 ka 4 na ko 4 3 12 4 4 16 3 ga ka adudi 9 yaudabra 450 sorry 1800 taramani answer tarbo yengom ta
Tare, sir.
yam thina live question ne ma si de mina ngamdri da ka Anjali kyan ta hobra Sunanda Lakshmi Sahila Saitabo Sinthoi kyan ta hobra
Tare, sir.
Tahu, sir.
tawai ka singe ka. So again adudi let's move on to the next question ka matam yam mangaloi se di matam yam phang deva. Question number 19 ji ko a black body is at the temperature of this, the energy of radiation emitted by the body at this is this, blah blah blah, which of the following is correct and yam live question ino isi ji khangadra yung question number 19 20 paro karamba hochige haro 19 to 20 su pulak ngamoidra. Question book yam yawi si sam tangai ko ka heat transfer question ya amini kamai loing amini sida aina ayukta no yaw ningba mina yawre aduga prakta mina tare toraga ayukta patlawna record to thoksira khangde class pulap just keno dang question dang solve to bagi ka. Question number 19 je ngamgadra tawzira tawrisira sasa ro we don't have much time.
Tawse, sir.
Tawse okay tawse aduna question number 19 is the 19 has again a black body is at a temperature of 5760 Kelvin. The energy of radiation emitted by the body at wavelength blah blah is U1. Okay, magi T is na 5760 Kelvin aduga si T1 ni and energy of radiation blah blah so lambda m is na have the 250 nanometer ni and sida labor energy is in a U1 and at wavelength 500 nanometer lambda M1 has lambda M2 sida magi 500 nanometer da अच्छा okay temperature is common never ko 5760 never ko aduga 3 different wavelength p ever ko aduga aduda khwaidagi common oibidu karambano na haidineba lambda m3 sina kayano 1000 nanometer harga moina sida leisina u2 sida leisina u3 neba adidi akoina kai khangi amatamda lambda m into t is equal to b neba ko aduna lambda m is equal to b by t neva. So b di kaino, b di 2.88 into 10 to the power 6 divided by t di kaino, t di man kay pirame 5760 pirame buko. Adu regadi cd 288 haraga 0 taruk nina ahum sure ko mari mga taruk divided by 5760 ko. So siko 576 C kaya agi perfect square no. Natrazu 4 na kakpaya bra yai ka. So 4 na ko 7428 ka. Then 4280 ahum aduga 414 4416 12 na ko 12 na kakshira. So 12 okay 144 12 na kagadi kay na the 12 7 la. Nati kay na 12 6 have 72 di ko. 6 yes 12 6 have 1 2 3 adu di 12 na ko adu di kay tare 5 have 1 2 so magi si 500 nanometer tayo ko adu na magi lambda m se lambda m is equal to 500 nanometer neba for 4k temperature T is equal to 5760 Kelvin. On a 500 nanometers yes, this is in a quite a hen a yam tadokaneva. Hybidi, U2 na quite a hen a yam nibuko. On a U2 na hen was the option number B tareko. U1 to tadokani, U3 to tadokani, and do a U2. Siseka U2 is greater than U1 hammer shizume. Adi U2 na the quite hen on option number Penuzita bring B is it bring option number B tabrang.
Right, sir.
Like so sir na solve to is gyan ta ho bro ma'am.
Right, sir.
Tai ko. Gyan ta da mi yaw bra gyan ta da di haro sir dum solve to bige ko. Ai di sir explain kong han na tawge ko. Sunanda tabra sunanda tat leme. Lakshmi tare ko. Audition thoi Anjali Saitabo Saila gyan ta ho bra lo ni mak.
Right,
Sir,
sir.
Tai ko. Ta dra ga di dum ta de he ko. Kem kai de. Sida moina TU is which of the following is correct? Have the quite maximum habidi sir na CC wins displacement lo the takib duneba. Magi maximum energy wavelength. Maximum energy wavelength have the quite the yam tadoku wavelength have ne buka. Wavelength CP ge energy budi chawdini but adu oi haiduna zumai sigi temperature sida di karambo wavelength na quite na chane hadi CC na chane ba. Auna mas sigi 500 nanometers na quite the masing yam tadokani ba. CC na kar handa tadokani ba ka adugi. Now let's move on to the next question. Question number 20 is the two ends of a metal rod are maintained at this and this. The rate of heat flow in the rod is this. If the ends are maintained at this and this, the rate of heat flow will be. So simple. CC kaino ngamgadra ngamoidra sa jainero. Rate of heat flow Z delta Q by delta T ni ko. Ngamgadro ngamoidro. So dimension de kay de everything loinamak chap manare ko. Magi coefficient of thermal conductivity so chap manarani aduna 110 minus 100 ka 210 minus 200 ka zi kaino have the chap manani ba. Aduna di kaino have the 4 joules per second adum ta ne. Option number B adum ta le ni. Gyan ta de. No response. Kaino ko nam response tok chisa. Thingjala pera. Lakshmi ta bro. Anjali Sinthoi Saila Saita boss kaigino
Oh, sir.
yaradro adu dia question number 20 is yaradra ba
Hold like yan.
keno gi wana te ko hola gi na ta ba gyan adum idin tadra na hai ni so gi ko kaigino si mangre ja song ji aina o isumai legi da na man yare So question number 20 are question number 21 sitting am gadrong 21 22 yeah. Question number 21 the has a piece of iron is heated in a flame. It first becomes dull red, then becomes reddish yellow, and finally turns to white hot. The correct explanation for the above observation is possibly by Araga Kaitani is a certain Kai Sigi exact Sigi when Hangiba question is certain Karita.
When
Example in Shinagi when's displacement low. Very good. Have the Magi lambda m do quite the yam tadoko masing yam tadoko wavelength to adu temperature ga inversely proportional oeva. Aduna temperature pi ngai dadi magi wavelength chawne have the rate thadokaneba. Aduga temperature si sum sum wangkhalakpai matungin wavelength pictharaga last the red dagi yellow, yellow dagi blue, blue dagi white in lakaduneba ko. Aduna this question is regarding Wayne's displacement low. It's about Wayne's displacement low. May am loni magyan tahu bra? Sige se.
Tahu, sir.
Tahu ikaw. Very good. 22 yang see. Two metal rods, 1 and 2 of same length, have same temperature difference between their ends. Their thermal conductivity are this and this, and cross blah blah. If the rate of heat conduction in one is 4 times that in 2, then si singam gadra si dum like ko. Question number 22 singam gadra. Sajai ro ngam gadra ngam gadra. Tauzira yadra. Kanam kumak tray. Pagi ye hadura. Par haro. Question number 22. I'm still waiting. Lakshmi, Saila, Saitabos, Sintoi, Anjali, Suranda, Haro. Kayino kanam kumak tiza. Lakshmi ngam madro si kise.
Hoi sir.
Ngamani buka.
C 어디
Haro Lakshmi haro.
산 C 어디 예.
Kayino tawdre. Nangi se voice to break to buka. Yes or no? Tawzira tawrosira yes or no?
야,
Yani bu tawdus yani buka. Anjali di yarbo.
야니 sir.
Saila yarbo. Saila ngasai de kumaktam ne. Ngasi Saila sum kumakte. Haro Saila. Yadra. Asik kumgi tawmaga kumakidre. Ta de Saila nangi do mute le ai nang mute pudi lautu ya khang ye sir da do no makonam to tholak te ba. Saitabos yadra. Saitabos kumaktre. Thieng bujile noi tumna kainum tawre da noi ji kumaktre da. Sarna phazul sarna pharga takpai mong da tawle. Question number 23 ji tawlo shela ji dur ga. Nei kana tawre. Sinthoi yarbo sinthoi. Yani buka 9:30. Okay. 9:30. Now, Sitaboski internet question number 23. If the radius of a star is r and it acts as a black body, what would be the temperature of the star in which the rate of energy production is Q? It's a very simple question. Sising am gadrang am 23 ji tawzira tawrisira sajainaro. Kanam ko magtre. Kayino kanam ko magtiza. Question number 23 see kaitani yenga dum haro option number A B C D. Rate of energy production do adudu power ni adudu kai ga chamane hai matamda sigma A haraga kai sigma A T to the power 4 oigidaba ko black body gida. So option number D yes sigma A haraga kai aduga T to the power 4. So the temperature of the sun in which the rate of energy production is in the rate of energy production is Q haiba aduragadi temperature yes chumme aduragadi ka si tarni yarba
Hoi sir.
temperature do T do hoi T do Q by erga ꯀꯩꯗꯧꯕ ꯍꯥꯏ Qꯁꯤꯅ ꯑꯁꯦꯡꯕꯗꯤ Qꯁꯦ Pꯅꯦꯕ ꯄꯥꯋꯔꯅꯦꯕꯀꯣ ꯑꯗꯨꯅ sigma A ꯗꯣ Tꯒ ꯄꯨꯜꯂꯤꯗꯅ T to the power 4 ꯒ sigma A ꯌꯦꯟꯊꯔꯅꯤ T to the power 4 ꯒꯤ 1/4 root ꯂꯥꯛꯑꯅꯤ ꯑꯗꯨꯒ ꯁꯤ ꯇꯥꯔꯦꯀꯣ D ꯁꯦ so question number ꯑꯩ ꯇꯧꯗꯤ ꯌꯥꯝ ꯇꯧꯅꯤꯡꯉꯤ ꯑꯗꯣ ꯅꯣꯏ ꯈꯨꯝꯅꯔꯛꯇ꯭ꯔꯦ ꯇꯧꯔꯤꯁꯦ ꯄꯨꯡꯁꯨ 9:40 ꯕꯨꯗꯤ ꯇꯥꯔꯦꯕꯀꯣ ꯉꯁꯤꯒꯤꯗꯤ ꯁꯤꯗ ꯂꯣꯏꯁꯤꯜꯂꯁꯦ ꯍꯥꯏꯔ ꯈꯔ ꯇꯧꯊꯈꯤꯁꯤꯔꯥ ꯁꯖꯥ ꯍꯥꯏꯅꯔꯣ again loishalase have the kem kai belate ko sir ju wadi waram ne do noine tawse haragadi I have absolutely no problem adum tawthagi dene pung pung tara bu to tharji ai ko some 20 minutes mo adu noine loishalase har su loishaladam ne tawthagi sira loishalase ra sa jaina ro anam ko matre sai tabo saro sinthoi saila lakshmi anjali sunda
loishalase ngasidi
okay loishalase ko okay fine ko adu dinga sigi si loishalase ko yare ko ma'am okay say sinthoi su loishalase ko good night everyone thank you for the class ko
thank you sir
okay good night and thank you